Where am I from? I'd like to acknowledge the countries on which we all are gathering across the whole of the country. I'm originally from a Wabakal land in Newcastle, New South Wales, and I'm currently living on Warramai and Wonnarua country, which is Port Stephens and Maitland in the Hunter Valley, New South Wales. And who am I? I'm a lymphedema physiotherapist and a researcher. My PhD was in lymphedema self-management education. I'm also the editor for the Lymph Exchange, which is the journal of the Australasian Lymphology Association. And I need to declare that I'm a volunteer for both the Australasian Lymphology Association, which is the professional national body in Australia, and also for the Lymphoedema Association Australia, which is the consumer national body. And I'm also a person living with lymphedema. So I've got lived experience as well as professional knowledge and experience. So tonight we're talking about lymphedema and all things lymphedema, and feel free to ask any question you want to clear up in your minds any understandings you need to have. And so we're going to talk about what it is and whether you might have it, will you get it, what you can do about it. And I'll also briefly talk about the Lymphoedema Association Australia and how it might be useful for you. So first off, the word lymphedema is a lovely long word made up of two subwords, lymph and edema. Lymph is from the Greek, which means, the edema is from the Greek. So lymph is actually from Latin, meaning the fluid of the lymphatic system. So fluid, basically it's fluid. And edema is the word for swelling. The Greeks knew about swelling, but they didn't name it lymph. So, or did they name it lymph? Interesting. But anyway, so it's basically swelling that's because of fluid from the lymphatic system. And we'll talk about the lymph system being perhaps affected by different things. So what the functions of the lymphatic system involve are four actual activities. So the first one is the fluid balancing circulation system, and it's probably the one most people associate with it because of the fluid and the swelling, but it's very important in our immune system protection of the body against infection and invaders. It's also part of the mediating of inflammation processes, and it's also part of our fat absorbing in digestion. So it's got four interesting functions that all interplay with each other and can load the system and what we expect from it. So when we talk about a circulation system, we often think about the blood circulation, and we're sort of vaguely familiar with this one, where the heart pumps the deoxygenated blood into the lungs, where it gets oxygenated, which goes back to the heart as arteries and out through the arterial system to the body, to the tissues, where they deliver, the capillaries deliver the oxygen and nutrients to the tissues throughout the whole of our body, deoxygenated back into the veins and back into the heart. But the third arm of that whole circulation system is actually the lymphatic system. And so from the lymph capillary bed, in the capillary beds, the lymph picks up extra fluid and the larger molecules and takes it back and dumps it back into the vein system just before it goes back into the heart. So the green on that diagram is actually the lymphatic system, and you can see it connects up in the top left-hand side to the veins there just before it goes back into the heart. And so the way it flows, and hopefully you can see the diagram as well as the words. I'm just moving my people across so I can actually see a bit better. The lymph flows back into the veins, and it's the veins as they're about to go back down to the heart, but it's actually under your collarbones in the subclavian veins that the lymphatics flow back into. So the green in this diagram are the lymphatics and the blue are the veins. And you can see that it's taken from, you can see ribs coming off and the backbone behind it all. And so what happens is we've got two drainage points back into the base of the neck. One is on the right and one is on the left. The body is drained in a series of quadrants. So cut your body straight down the middle and straight across at the waist, and you've got two upper quadrants and two lower quadrants. So
I just wanted to say, please don't try that at home.
Yeah. Figuratively speaking. So, yeah. So the left drainage point actually has to drain the left upper quadrant and both the lower quadrants. So below your waist and down in your legs, all of the fluid coming up through that the green thoracic duct that's running there in the diagram, going all the way up and coming in. So it's got a lot to do, whereas the right-hand duct only has to do the right upper quadrant, so the head, neck, and arm and chest. So it's interesting how there's that asymmetry. Okay, two more diagrams, and I'm going to show you lots of different diagrams because I often find that everybody picks up a little bit of something different from the diagrams, which is great. And don't worry, because I believe you're going to be getting a link to the recording, so you'll be able to watch this again if you miss anything as we're going through the first time, and you can go back and check on things. So basically, the chap on the left-hand side is giving you an idea of those larger ducts that run from the body, from the limbs through the trunk to drain back in. And the one on the right is showing a lot of nodes, lymph nodes, the little round dots scattered throughout, especially around the head and neck and down in the groin and the axillas. But they also are showing a couple of other things like the spleen, the thymus, the liver, and the bone marrow. And that's because they're involved with those other functions of the lymphatic system, which is the fat absorption and the immune system as well. So the way the tissue fluid is returned to the bloodstream is by lymph capillaries, which capture the fluid, lymph collectors, and the lymph collector vessels pump the actual fluid, and we'll go through this so that you understand how it pumps. And then it goes through lymph nodes, which filter the fluid, and then the lymph tracts empty the fluid back into the veins. So we're going to have a closer look at lymph nodes in particular and the capillaries to start with before we get back into how it all gets back into through the system. So basically, lymph capillaries are the tiniest of the lymphatic vessels, and they are woven in amongst the capillaries of the blood vessels. So the blood capillaries are the arterioles, meaning very small artery type vessels. So the oxygenated blood comes in under high pressure, and they go through this network that wraps around and gets in deep where all the tissue cells are. So the cells of all the cells of the tissues, all the tissues in the body are fed through the blood system, and then the lymphatics and the venous system help to remove the deoxygenated blood and any leftover products from the cell's activation and living processes. So basically the fluid comes through and enters the fluid that's around the tissue cells. So the cells are bathing in fluid all the time. They're not stuck together. They've actually got a bit of fluid between them all. And the fluid from the seeps through the wall of the blood capillary so that it will allow certain chemicals to go out, certain molecules to go out, proteins and the like. And then once it's out there, it gets taken up by the cells through their walls, any nutrients that they want and the oxygen, and then they use it in their processes and then create byproducts, which they then jettison out. They don't want to keep it. They put it out into the tissue. And those are the things that, those are the molecules that have to be worked. How does the body get rid of it? Only the small molecules are able to get it back into the blood capillaries because of the way they're formed. And so all the larger molecules have to go via the lymphatic system. So you get a lot of protein in the fluid that is taken up by the lymphatic system as well. And so the other difference between lymph capillaries and the blood capillaries is that the blood capillaries all link onto each other, whereas the lymph capillaries actually start within the tissue bed and then flow from there. So they've got like a dead end starting position. And that's this is another diagram which shows the capillary, the end point of the capillary. And you'll notice that what they're formed by are actually wall cells. So they're cells of a certain type to make to actually form the capillary. And these are actually designed as like little flappy things. So they overlap each other, the edges overlap each other. And you'll notice in this diagram that there are black tethering ropes, so like black tethers. And these are tissues that attach to the matrix of the tissue of the cell, what the organ or the tissues that are involved. So that's the solid structure that keeps everything together and in one place. And so these tethers are an amazing, I just find it completely amazing how they function. And it's just simply so that they can absorb the fluid in. And so the next diagram is the cycle that goes on. So if you actually look at number A, which is at the top, what we've got here is the end of the capillary, which is actually collapsed down and empty. And you can see that the tethers are all very loose around it. And what happens is that the cells are busy doing their thing and letting the fluid out that they don't need anymore in the proteins. And that will create a small localized tension building. And so the tethers are actually stretched away, open the flaps to allow the fluid to go into the lymphatic capillary. And then once that happens, then the tension goes off the tethers and they shut again. So the fluid is actually held in simply by mechanical pressure forces. But of course, this is now in the bottom diagram, it's now full of fluid in one section, and the valve to the empty section further down the capillary is leading to a low pressure area. So fluid flows from high pressure to low pressure. So that's exactly what happens in section D, where the valve opens and the fluid flows down in the capillary. And then the tissue tension is much the same as it was to begin with. And then the cycle goes on. And this usually happens sort of every 6 seconds or so. There will be a basic pumping of the lymphatic system happening. So this is where it all starts, down in the capillary bed. So that's just the two diagrams. So you can sort of have a look at the 3D sort of model and then have a look at the simplified structural model on the right-hand side. Now, when you consider that every tissue of the body has lymphatics capillaries in it, I just drew this one up from an example of bladder cancer because I thought it was relevant to the group we're in. And so in the fatty layer, there are lymphatic vessels. In the muscle layer, there are lymphatic vessels. In the connective tissue, there's lymphatic vessels. In the epithelium, there's lymphatic vessels. And in the tumors, there are lymphatic vessels as well. So every part of the body, every tissue in the body will have a lymphatic capillary system. And some of you might be saying, oh, what about the brain? The brain has a specialized system called the glymphatic system, which also drains lymphatic, the fluid to the lymphatic system as well. So it's just, I find it quite amazing. So just keep that in mind, that everything is draining from everywhere, and especially the areas that have been affected by your cancer, even before you've had any treatment. So from the small capillaries in this diagram, it's the sort of the pale bluey things, the capillary, lymph capillaries. They all then connect into the pre-collectors, which are slightly larger lymphatic vessels, which then go on to be a collector. And it's like a transition over from being not quite a capillary and not quite a collector, because the structures change. And it's the structures in the walls of the capillaries and the development of valves within the system that really make the difference. So this is a nice diagram that shows the change from on the right-hand side, there are capillaries, and you can see that the edges of them are those lymphatic endothelial cells, the ones with the flaps attached to the flappy ones that can open to let fluid in and out. And then you get the development of smooth muscle cell wrapping itself around the actual collectors. So there's some smooth muscle, but also lots of flappy bits in the pre-collectors. And then gradually, by the time it gets to the collector, each section has smooth muscles around it, and each section has a valve before and after it. And that section is actually called a lymphangion. And the word angion, sort of like angina, it's like a heart. So it pumps like a heart on its own in accordance to how the autonomic nervous system is working, and also other local factors like stretch receptor input as well. So if we look at the lymphangion, here's another blurry diagram, just to really highlight the fact that there are valves which direct the flow down the collector in a certain direction. So most of them will flow only in one direction, except when there's a fault and there's a buildup and it doesn't flow away properly. And then you can get a stretching of the lymphangion to the point where the valves become weak and don't function as well. So that will allow regurgitation and backflow of the fluid. Sort of like varicose veins can happen if their valves fail, then lymphatic valves can also fail. So one of the important things about lymphedema is working with getting it flowing so that those valves get a chance to maintain their shape and function. And here's another diagram, it's just a diagram, but you can see that between the two valves, there's this rounded sort of section. That's the lymphangion. And just imagine wrapped around that, spirally around it, is this smooth muscle that is the lymphangion pump that pumps every 6 seconds by default, but it can speed up to every 3 seconds. So that's if you're trying to get your lymphatics to work faster, you want to get up to the double speed so you can process more fluid at twice the speed. So, okay, we'll talk about lymph nodes next. So this is a diagram for indicating a lot of lymph nodes are around the region of the bladder and up towards the kidneys as well, deep within. And so the main purpose of lymph nodes is to filter the fluid, to defend the fort, to find the baddies and chuck them out or lock them up, or alert the authorities. So they're the pathogen defenders and immunity adapters, and they're also the recycling system of the body to a certain extent. They break down products into smaller parts. So within the lymph nodes, you get the activation of lymphocytes, the B cells and the T cells. Now, we've heard a lot about B cells and T cells and things over the last few years, and immunity and antigen productions and all that sort of thing. So the lymph nodes are very important for protecting us, and they have a lot of lymphocytes held within them, just waiting to go into action. So it is like a guard tower in a castle fort system, where the guards are in the tower waiting for work to be done and on guard, but just waiting to be alerted and put to work. And the other thing that's produced in lymph nodes is the macrophages, and I love macrophages. They're very much like Pac-Man. I don't know if any of you ever played Pac-Man in your life. Those lovely little munchy things that you chase around things and you chomp them to pieces. And that's exactly what macrophages do. They break down the larger molecules. And remember, we were talking about how the large proteins come back through the lymphatic system. Well, the macrophages help to break down those proteins into just the amino acid pieces. Think Lego block destruction. And that's reabsorbed into the body and can be reorganized and reused, or it can be eliminated, and it's just easier. The other thing it can do is actually break down the structures of bacteria, viruses, and even there are special cells that are used by the body to kill cancer cells. So the killer cells can be activated as well if any cancer cells happen to stray in. But let's have a look at macrophages first of all. I love macrophages. So here's a lovely diagram of what they actually do and how they do it. So on the left here, we have the macrophage, which is that funny shaped cell, and it has its own nucleus, which is its powerhouse that gets all the energy to do what it wants to do. And it has the lysosomes, which are little like hand grenade things, if you want to think of it that way, they're chemical hand grenades. And so what it does is if a bacteria comes by or a virus or something comes by, the macrophage goes up and gives it a wonderful big welcoming hug and totally surrounds it, 3D surrounds it with its own body. And it creates this phagosome area to hold the bacteria in. And then what happens is those little lysosomes, those little defense grenades, pop in alongside the bacteria and then go boom and blow them up. And then the macrophage burps them out. But they also create, if it's a bacteria, it'll also create an antigen, which just gets into that lymph node, but also circulates throughout the body, so that if any other bacteria like this comes again, immediately they will be attacked by the lymphocytes within the system. Here's another diagram of a lymph node. So you have lymph vessels coming in, the afferent incoming lymph vessels, and you've got a lot of structure within that, that the fluid then has to be filtered through. It's really like going through a net, a fine net, so that all these little black dots are actually those lymphocytes that are on guard and watching. And so to get through a lymph node takes a lot of effort by any infection and also cancer cells. And often the cancer cells are surrounded by lymphocytes and almost like they build a brick wall around them to try and contain them within the lymph nodes. And of course, because it tends to do that, that's why lymph nodes are often taken and sampled to see how far your cancer might have spread, because they're very good at trapping the cells here. And they're so the fact that you've had lymph nodes out and they might have had cancer in them, often people get a sort of negative feeling towards the lymph nodes, but actually they've been doing you a big favor. So they've actually been fighting alongside you all the time. So that's basically what happens. It eventually gets down to that bottom section where the lymph flow keeps going through to the next collector, which takes it away through maybe a couple of nodes. It might go through several nodes before it actually ends up getting back to the tracts that end up in the veins, so that you've got a lot of defense happening in your system. It also mediates a lot of the inflammation processes. So if you get a lot of the inflammatory chemicals coming through, then the lymph node will also alert the body to the fact of maybe we need to be more inflaming, send us more troops. Or maybe we need more defense, send us more troops. So it also will activate the rest of the body. And that's where those bone marrow and thymus and spleen come into play, because the spleen holds all the stem cells that will go on to become lymphocytes. And so if they need more troops, it sends a message to the spleen that they need to get more things happening there. And then the T cells are formed in the thymus gland and the B cells are formed in the bone marrow. So that's why they were all included in the lymph things. So you may get cancer in more than one lymph node. And so very often the way the surgeons work out which ones to take in order to sample is that they will use some sort of dye that they can track in and work out which nodes they go to. So they're the ones that they take. And so they try to minimize how many lymph nodes that they have to take in order to sample to check. So overall, this is sort of like a diagram of the lymphatic system overall. So the red part is the artery, the purpley part is the capillary, and the blue part is the vein. So that's the blood circulation. And the fluid moves across, and oxygen and nutrients move across the fluid to the cells. The other fluid then can get into the lymph capillary, go down the capillary into the lymph collectors, through the nodes, and back through the tracts into the blood system. However, things can go wrong with that flow. So the first thing that can happen is, yes, you might develop a cancer within the lymph node, which blocks up some of the channels, so the rest of the fluid can't get through, so it slows down the fluid. That might be one thing. Or you might get an infection that creates problems. Think of how much swelling you get if you get a case of the mumps, although these days I don't think kids get mumps as much as when I was a youngster. But you'd get, not only your glands would come up, but the whole of your face would swell, and that was because of the backup of the fluid. So that's one problem. If there's a problem with the transit through the node. The next problem is if there's a problem with transiting the fluid from the fluid near the cells to the lymph capillary. And this can happen very commonly with radiation therapy because you get a lot of scarring within the tissue. And so all those scar fibers stop the fluid from easily flowing through its normal channels. You can also get a surgical cut, which will give you a nice little scar that will block it, so it stops the fluid flowing through as well. And then, of course, you can have damage to the actual lymph capillaries, the lymph collectors, and this can also be part of radiation scarring, so that the muscle parts around the lymphangions get scarred, so they really can't work as efficiently. Or it could be surgical once again. And of course, if you have your lymph nodes taken out, that's exactly what happens. You lose that channel through that particular lymph node as well. So when things go wrong, lymphedema forms, and it's
Oh,
to do, yeah,
Tony, can I interrupt for one
yeah,
second? Because there
sure.
were questions about this, just going back to your
Yeah.
other slide. So just what happens from a surgical point of view, unless you're still going to talk about this, what Sally's talking about here is really, really small. Like you need a microscope to be able to see these lymphatic channels. And so when we operate, we don't use a microscope to look for them. It's literally, and also they're very hard to find because they're usually embedded in big pockets of fat. If you think
And
of
the fluid is clear, so you can't see it, whereas you can see the blood because
blood,
it's either blue or sort of a bluey color or a bit of a reddy color, but it's clear.
exactly.
It's the fluid of lymph is the same as, you know, when you've had a splinter in your finger and the clear fluid comes out, that's actually lymph fluid. So you can't see it. It's very hard, except like you said, if you have a microscope, and there's not that many surgical microscopic procedures, I believe, for bladder cancer at this point. So
No,
it is being experimented with yes, of course, breast cancer, because everything happens with breast cancer, doesn't it? But it's still in the exploratory phases as well. So at
thank
this,
you.
yeah, so don't diss your surgeons, because they're doing the best for you. And
Yeah,
they
of
do
course.
try to minimize the trauma that's involved as much as possible, so that there's yes, as little damage as possible. And we do have a massive lymphatic system. So what can't get one way can often find another way around. It's just that if it doesn't find the other way around, that's a problem. And we'll go on to explain that a bit more. And you can get this from any surgery or injury. It's not just cancer surgery. It's also orthopedic surgery. You often get people developing lymphedema after those sorts of things. And even some traumas, just people falling badly or injuring themselves and developing scarring within their tissues can also lead to lymphedema. Yeah. Did that answer that enough?
Thank you. That's great. Thanks.
Um, so getting back to when things go wrong. So it's this whole thing of preload, which is the amount of fluid in the tissue cells that needs to be drained, and the capacity, which is of the capacity of the lymphatic system to actually get that drained out in a certain time. And so there are two main ways it can really go wrong, and that's when the capacity is reduced, and that's through trauma or the malfunctioning vessels. And so that's when you don't have as many vessels flowing, and so it's like a freeway accident. If your main channel of getting your fluid out tends to be down the main highway, and then suddenly there's an accident and that's blocked off, then what happens, everybody's probably experienced that, is that if you can't get off before you get stuck, then you're stuck for ages trying to get out of the system, and you have to go around, and it takes a while, and everything banks up. And so that's virtually what can happen, especially if it's quick and it happens. When and the second way is if the preload outstrips the capacity to drain, and that's sort of like a flash flooding event. So it's actually equipped to deal with quite a bit, the lymphatic system. But then if you suddenly load it with something, like if you sprain your ankle and you get a lot of swelling, then you will get swelling in your ankle And it takes a while for the lymphatic system to get that swelling down. It might take a couple of days, but it gets it down. Okay, so that's an example of inflammation creating a preload that outstrips the capacity. But then you can also have a lot of health conditions that do it as well, such as high blood pressure will shunt more fluid into the tissues. You can have diabetes, where if your sugar levels are out of control, you will get sort of leaking of fluid into the tissues. Some thyroid conditions as well can impact it. And anemia can also create a load, a shift and load into the system as well. And so that's like flash flooding. That's like, normally I'd be able to drain this away within a couple of hours, but because I'm doing 6 days of something or other that's loading it, whoomp, I can't get it away in time. And so everything backs up and you get the swelling. And I've got some diagrams to help us understand that a little bit more here. So that when the preload outstrips, then this is what it looks like. So the orange part is the transport capacity. So that you can see that we've got a massive amount of capacity to transport lymphatics. So normally we go around flaring up the load and our body just copes with it and we don't even notice. It doesn't create a long-lasting effect. But what can happen is that it can increase, the load can increase, and we're keeping up with it, but there's a lot of load. And then suddenly there's more load than we can cope with, and then we develop the edema. So that's that way. And then the other way, trouble progressing, right on. Oh, there we go. The other way is if the capacity is reduced, and that's, say, we've happily going along in life, and then we damage something, get a scar, and then we might have surgery, and then we might have chemotherapy, which is a taxane base, which sometimes can create problems with inflammatory responses in structures. And then we have radiation, which completely knocks us out. In fact, radiation is probably more damaging than chemotherapy and surgery put together. And that's even taking out nodes. So the radiotherapists, the radio-oncologists, anyway, those specialists who in cancer radiotherapy are one of the ones that are trying really hard to reduce the impacts of radiation treatment on people for the lymphedema sake, because they have been aware that they have been causing a lot of damage. But hey, we've got to have it if we've got to have it. Thank you. Yeah, so gradually it gets to the point where we just don't have the capacity, and so it doesn't take very much at all to create an edema. And so basically our aim in life is to keep our capacity as good as possible, keep our body flowing, and to reduce the preload. So that's basically. And the other thing is that if you have lymphedema, then you can also, it can actually help things go wrong if it's not got under control, because if you keep fluid in tissue for long enough, the tissue will actually try to increase its matrix to try and stabilize it, to stop the fluid from damaging the tissue cells. So it'll create its own fibrosis, and that creates further loss of flow. And if you have chronic edemas, because of they cause a cyclic inflammatory response. So inflammation is a response of in lymphedema. In fact, a lot of lymphedema is considered to be inflammatory mediated, and a lot of the research at the moment is trying to find something that will cut that inflammatory response out to improve lymphedema. So if you have a chronic edema that's just sitting there all the time, it will increase that inflammatory response. And then it also, because it's nice and protein rich, it's a wonderful space for infection to just get in and breed. And cellulitis is an incredibly incapacitating infection of the tissues, and it can lead to hospitalization, because it can also get in the bloodstream and cause sepsis. and we won't mention the D word at the end point if it's really bad. But yes, so it's people with lymphedema in fluid in their tissues, especially skin areas and legs in particular, are very prone to cellulitis. So it can create its own inflammatory response, which then destroys more of the lymphatic vessel structure as well. So it doesn't work as well.
Here's a question for you.
Yep.
Is all edema in the body lymphedema?
Oh, I've just been on a discussion session today, and we were discussing chronic edema. It's in a definition. Okay, so all edemas will be processed by the lymphatic system. Technically, it's not a lymphedema unless the lymphatics are not working enough to get it by. So yes, other edemas, of course, cardiac edema and from kidney failure as well, are also problems. However, management of those edemas, apart from looking at the source of what's causing that edema, is also lymphatically informed. So it's a word, isn't it? It's a diagnosis. It's a term, a constraint that we put on it. But yes, all edemas in the body will be processed by the lymphatic system, if that answers. So technically, no, not all edemas are lymphodemas, but all edemas will go through the lymphatic system.
Yeah, I think that answers it.
Is that okay?
Yeah,
We
yes.
can talk about that later anyway.
No
Trust
worries.
us, we've already had an hour today talking about that. But that's good because discussion is important. So the final thing I just wanted to mention is that the fat digestion via the lymphatic system does have an impact on us when we're considering preload. And we can actually preload our lymphatic systems, especially those systems draining from down below, by what we consume as far as fat's concerned. And so what happens is the smaller free fatty acids, the small chains, the single chain fatty acids, tend to go straight into the capillaries, the bloodstream, via the hepatic portal vein to go to the liver to be processed and used. Whereas all the other ones, the longer chains, all end up in the lacteals, which are the lymphatic system within the intestine. So I'll just show you the next diagram. So if we actually take a section out of your intestine and have a look at the inside, it's all full of these little ruffled ups and downs and frilly bits. And this is a close-up section of that frilly bit. And so within the bumpy bits, you've got a lymphatic vessel, once again in green, and surrounded by the capillaries, because, you know, they all go together, the three amigos. And so that's where a lot of the fat goes into the lymphatic system, and then it has to go through the gut into the cisterna chyli, it's called, which is like a bigger sort of section where a lot of lymph sits. It's just below your belly button, in quite deep, and it's where all of your fluid from your legs also tends to flow through. So if you have a big feed of fried fish and chips, you are preloading your lymphatic system. And so all the fluid that's coming through from your legs then has to compete with that load as well. And you've got to have a really good system to clear it all. So if you don't, what tends to happen is that fluid with the fats in it will actually backflow into your legs, and you might actually get little blisters that are white. The fluid in it looks white, and that's where the lymphatic fluid has mixed with the fat, and it gets a little milky white. And that's one of the first ways they discovered lymphatics, was because they observed this white milk, and that's why they're called lacteals as well. Alrighty, so let's get on to the burning question. Will you get lymphedema? Well, the answer is not perhaps nice. Probably, maybe, perhaps. It's not very defined. And I think the thing is that different studies have different numbers. But what I can tell you is that anything below the waist tends to have higher numbers of percentages of people within the population that will develop lymphedema. So it's between the different studies, it's between 35% and about 95%. And that's anything below the waist. Now, I couldn't find a specific one for bladder cancer. Do you know a specific lymphedema incident for bladder cancer treatment?
No, I don't actually. But
I
while you're
couldn't.
talking, I'll see if I can find it.
Yeah, I really, I searched everywhere. I'm thinking, oh, surely there's a whole lot of other cancers, they've got them. But I couldn't find one for bladder cancer. So it's just a curiosity of mine, exactly where it sits amongst that below the belt. But basically, you've got about a 30% chance of developing it. So, and what are the signs and symptoms? Well, swelling is the obvious one, but swelling isn't the first symptom, because swelling is the end result of the tissues filling up. At first, you get all the other things. So you get feelings of heaviness, aching, pins and needles or numbness, because you've got the lymphatics within the nerve tracts actually swelling up and pressing on the nerve cells so they don't function properly. You might have that, you notice that your clothes are feeling a bit tighter, or you might have a sock imprint. When you take your socks off, you can see a mark, an indentation, or you might have a cuff from your clothes, or you might say if you're sleeping and you get a fold in your pajama pants and you wake up in the morning and you have a mark, an indent in your where you've been lying on it, that could be an indication that you're starting to get lymphedema as well. And then the frequent infections we've talked about in the legs. The skin actually changes in structure because it can't get an adequate nutrition to it, because the fluid from the lymphedema will actually block the blood flow and the nutrients getting to the actual cells on the top of the skin. So you often get dry skin happening. And because your body's working so hard with all of this, you often get fatigue as well. So when you look at what does that look like, they've put up 4 stages in this picture, but there's actually a stage 0, which just means no swelling. So we actually have a stage 0 in lymphedema language. And that's preclinical, I think they call it, although you've got all the other signs and symptoms can be happening. But gradually you can see the change, the loss of the indentations and the definitions of where the ankle is and the knee. And gradually you get these lumpy and bumpy bits, and the tissues actually change into much more fibrotic. So that stage 4 is very fibrotic and dense feeling, whereas stage 1 would probably still be fairly soft, and you can do a pitting test where you put your thumb in for 30 seconds and then you can actually see the indent, or you can feel the indent that's happened from that. The other way you can, I'll talk about monitoring later. So they're the stages. Oh, monitor. I was in the right spot. So the other way is to, if you're worried about, am I getting it, is to monitor your body for changes. So get to know your body. So feel your tissues. Are they soft normally, or where are the bones in them? Is one side different to the other? Because very often lymphedema presents as an asymmetrical sort of fluid pattern. So you might find that one side is more solid than the other and feels full. You can test by pinching. There's a pinch test where you just grab the skin and check the thickness of the how much the bit of that you've pinched is. And if one side is thicker than the other, it's a very quick way, and you just do it on exactly the same spot on either side. Usually the technical one is on the feet, but you can do it anywhere on the body. And then you can also have bioimpedance measures, which is the terminology is LDEX, L for lymphedema and DEX for index. And often they call them SOZO testing, which is the brand name of the machine itself. Not everybody has a bioimpedance measurement machine. And so they're few and far between. But if you can find one, you can often get a measurement done as well. So the other things you can do is to protect yourself from triggering it off, or and that's importantly avoiding weight gain, exercise and movement, skincare, good general health maintenance, and that's to do with decreasing the preload. So make sure all your other health conditions like your diabetes, your hypertension, your thyroid conditions, your anemia, everything else is working and even arthritis, make sure it's all under control and you're in top condition for whatever other conditions you have. Stress management and relaxation are very effective ways of reducing the cortisol within your body, but also if you are stressed, you switch your pumping mechanism back down to the default every 6 seconds. As soon as you have a stress response, you go back to slow-mo. So what you've got to do is get a relaxation response so you can start pumping happily again. And so that's a very effective way of protecting your lymphatic system, is to learn to induce a relaxation response so that when you're managing your stress, yes, you get stressed, but then you can relax afterwards. Like I'm going to do after this presentation, I'll do some meditation and chill. Have an anti-inflammatory lifestyle, and that's to avoiding eating things that tend to create inflammation, and to stick to an anti-inflammatory diet. And make sure that your diet also includes protein and fluid. People often restrict that when they think they're doing themselves good, because it's lymphedema is a fluid problem and it's a protein-rich fluid, so therefore I'll get rid of them. But actually, if you do that, you create problems. A high protein diet is advised, and a lot of hydration is advised. And also sleep. You need to have good sleep, because once again, that works on all that chemical responses that help to keep everything pumping well. And most of your brain drainage happens at night when you're asleep. So you need to get some good quality sleep so that you drain your lymphatics from your brain, which is very important as to prevent things like chemical depositions that cause dementia in particular. So other triggers to avoid to reduce overloading is heat, sunburn, inflammation, infection, there's a big list there, but basically anything that creates a reaction in your body. Strenuous exercise will load you initially, but it usually reduces over 24 hours to 48 hours. You actually get a much emptier lymphatic system after that time. But if you've got a problem and you're trying to avoid triggering it, you may not want to be doing extreme sports. So all those would-be Olympians at the moment, just back off a little bit and go for the slightly gentler exercise routines. Doesn't mean you can't do it. It just means you have to train your body up and know what your body can cope with in order to do extreme exercise. Standing still and static muscle activity, like driving for a long time and not stopping, are also not good for lymphatics. So if you've got upper limb problems, that's an issue. But standing still is particularly, or sitting still with your feet dangling down, are also a problem for legs in particular. Hormonal fluctuations are also an issue. So you've got to try and keep everything under control. And of course, women are always blessed with all these extras, aren't they? And pregnancy. Changes in barometric pressure. There's a lot of anecdotal evidence about that. It hasn't been fulfilled in any scientific experiments that are of good quality. And the other issue that triggers it often is travel, and people often think it's to do with the cabin air pressure. That only affects a very small number of people. In fact, it's more likely to be the fact that you're sitting still for so long, the fact that you often get dehydrated with the air conditioning in the planes, the fact that you've just carried an incredibly heavy suitcase that you're not trained up to carry, or that you're stressed about the travel, can all trigger it off much more likely than the cabin pressure.
And could it also be from the veins as well, if you've got
yeah, definitely, because
insufficiency?
Yeah, I mean, that's why on the airplanes they do all the move your ankles and exercises and everything, is because you get that tendency for the veins. And if you've got vein problems, you need to have your veins fixed in order to not load because any venous edema will create a load, which then has to go through the lymphatic system. So you need to get that sorted as well. So any condition that puts extra fluid load, you need to have fixed. You have to get onto that and fix that as well as manage everything else. Life gets very busy sometimes. Okay, so just quickly, things that you can do to reduce it is to look after your skin, keep your weight under control, keep moving, so move frequently. And we've been sitting for a while, so you might want to be wriggling your toes or swinging your legs or moving your knees up and down a bit. Make sure after you've done activity that you do slow cool down movements as well, so that you help pump away that excess that comes from exercise. Use antiseptics for cuts and bites. Use anti-inflammatories, but not ibuprofen, because there is a study going on in America at the moment. But one of the preliminary findings was that if you take any ibuprofen, you will actually make your lymphedema worse. And it was used as one of those testing, not quite a placebo, but they were looking at other, from the drug that they were testing, they were looking at other similar drugs to put in and compare the results of other drugs on the market. And it was a surprise finding, but ibuprofen actually makes it worse. Stanley Roxon is the person, if anyone wants to go in and check his work. The other thing is use antibiotics promptly if you get any cellulitis happening. So you want to get that under control as soon as possible. Or any infection if you get a thorn in your system and then it gets infected, you need to make sure that if the antiseptic doesn't seem to have worked, that you get some antibiotics from your GP as quickly as possible. Stay cool, so avoid the heat, but also stay calm. So the other thing is the stress. Avoid any trauma if you can, and train up for your exercise levels so that you don't overload your system before you're ready for it. So what can you do about it? Early intervention, find a lymphedema therapist, and through the APA, the ALA, the VODA Association, the Casely-Smith Association, just to throw some names at you. And therapy involves measurement, assessment, and diagnosis. So a trained lymphedema therapist will be able to assess you and clinically diagnose you and take measurements. They will be able to do therapy for you, and they'll be able to prescribe in particular compression garments, which is one of the most universally used things. Most people end up in compression garments if they're beyond stage 1, and other things as well. But they'll also teach you about self-management, what to do as far as exercise, movement, compression, skincare, elevation. There's so much you can do. It's amazing. So there's a lot that can be done. So getting in early means the job isn't as hard to get it under control and keep it under control. So where to go? The Australasian Lymphology Association has a Find a Practitioner register. They actually have accredited practitioners. So they've done a training course that they accredit, and they also are maintaining hours of education, follow-up education, and also have a certain number of hours per week that they use. They're working in the clinic as a lymphedema practitioner. So that's great. So you can trust these guys, okay? Go on and you can find these guys. And you do it by postcode search, and you can search out for it. The thing is that not everyone who's a lymphedema therapist who's been trained with an accredited practice will necessarily fall under this, because most of the public hospital physiotherapists, lymphedema therapists, most of the hospital lymphedema therapists don't end up on this register, although they're trying to work out how they can do it. For example, I don't actually end up on this register because I don't do enough hours per week to actually allow me to be on this particular register. But the other way you can find it is, say, through the Australian Physiotherapy Association. And when you go into their Find a Provider Practitioner page, or Find a Physio, I think they might call themselves, you need to select the special interest area of cancer, palliative care, and lymphedema. And then you will find the people involved, because not every physiotherapist understands this or has the knowledge to manage lymphedema. So you need to find someone who has it. So they'll be in this lot here. And then once again, you put in your postcode, you put a distance that you want to see, and then you find it. And this is, so I'm on that list there. And then the other way you can look for services is through the Lymphoedema Association page, and they do it by state by state. So you go onto this page and you put in your state, and they link you in with different like the VODA group and the ALA. And then they also have garment schemes for each of the states. So you get some subsidies for different things that are available in different states. So each state has a slightly different support scheme for garment supply. And also things like some of the states, you can get an electricity subsidy as well for air conditioning and things like that. So that's another way to find a service. But in the meantime, you can be doing some deep belly breathing to increase the flow back towards the heart, which drags more lymph into the blood system as it goes along. It also increases the flow up from the lower parts of the body through that thoracic duct, because of the diaphragm moving up and down and actually milking it, and the change in pressure between the chest and the abdomen as you take breaths. So remember, high pressure to low pressure is the flow. So when you take a deep breath in, you've got lower pressure in the chest. And if you've got higher pressure in your stomach, then it will flow up towards it. And that's how that thoracic duct tends to drain. And of course, deep belly breathing also helps the relaxation response. So you get that extra pumping speed happening as well. So deep breathing is your first line of do-it-yourself sort of stuff, but it has to be that belly breathing, getting your belly expanding as you breathe in. Exercise and movement works because the muscle contraction on either side just gives that extra squeeze to the lymphangion. So it assists the lymph pumping, as long as it's doing every 3 seconds. So if you do a slow movement, so every 3 seconds, it will help that lymphatic pumping along. Static, it won't help because it's just holding it and squeezing it. But if it's pumping, if it's moving. So good exercises include things like Tai Chi or Qigong or yoga. But any movement that's rhythmic, swimming is fantastic as well. So all of those things are very, very good. Compression is, like I said, the key component of getting that swelling under control. And keeping it there. So usually if you've have a lot of swelling, what will happen is that your therapist will bandage you over a series of weeks to get you down to size. And there are two main ways of doing that. And then once you're down to size, they get you into garments, which are usually either socks, stockings, or pantyhose for lower limbs. And if those are too hard to get on and off, they've got wraps now that they've developed, which are Velcro pressurized garments. So they're actually made to sort of fit your body, and then you Velcro to a certain point. And there are also garments that you can wear at night that also function best when you're horizontal. So they're not meant to be when you're up and about. But they also work to keep some flow happening, and they've got some little special things involved in that. And then there are also compression pumps of various sorts that actually help. The segmental ones are great, where you get a squeeze happening at one point and then the next point, then the next point. So it sort of mimics the flow down as well. So there's a lot of ways that compression can be used to help. And skincare is one of the most important things. In some of the third world countries where they can't afford garments and bandaging and things, just improving their skincare has great benefits, and they've had a lot of good results. So the important thing is to maintain your skin integrity so you don't get any openings up, because it's your first line of defense from infection. And so you want to make sure that you keep your skin intact. And of course, if you've got lymphedema, as I said, it stops your skin getting the nutrient it needs. So you really need to work harder to really improve the condition. So cleansing and drying well, moisturizing, and inspecting for wounds and openings, and then disinfecting them. So particularly between your toes, your little toes, fungal infections, and the cracks in your heels. No cracks are allowed. When you've got a risk of lymphedema, you need to be working on getting your feet absolutely brilliant. and trying to avoid anything like treading on things. So make sure you've got shoes on or some sort of protections wherever possible, and avoid getting your skin sunburnt or insect bites and allergic reactions, which will get that flare-up response that your lymph system has to then and your skin has to work through. So do the best you can to look after yourselves. Okay, quickly, the Lymphoedema Association Australia. It's there for people with lymphedema. Goals of awareness, support, education, and advocacy. There are support groups locally. If you go on their page, you can maybe find a local one. We're always looking to build more of them, but there is also an online support group. And yes, I'm one of the leaders of the online support group, and you're all used to online support groups meetings, so that's great. We have a social media Facebook page and Instagram account, and webinars and info days are being held. There's one in South Australia coming up next weekend, I think it is, or the weekend after. And there's one in Melbourne later this year as well. So information's on the webpage. We also have a big campaign in Lymphoedema Awareness Month in March called Shine a Light on Lymphoedema, and we try to light up Australia blue and get as much information into the local papers as possible. So you're more than welcome to come on board and help us out with that. And they also have Node News, which is like a newsletter that they produce 4 times a year, I think. And e-newsletters every month come out as well, keeping everybody informed and with, you know, information and articles on tips and tricks and all sorts of things as well. So it's a really good organisation to link in with if you have lymphedema, and it's got a lot to help you through the whole process. Okay, so just summing up, lymphatics are sort of like spring-fed. They're constantly happening. The fluid is constantly being produced. And it starts off from a spring, and then it joins a creek, and then a creek gets into the river, and then the rivers join together, and eventually they come out to sea. That's actually Newcastle for those people that don't know, in the Hunter River, and that's Nobby's Lighthouse that you can see. And so it's sort of like that eventually the river water turns into the ocean, and it's like lymphatics eventually turn into the bloodstream again.